Hey guys, let's look at lab number 3 where we're going to look at a graphing review. So we're going to talk about different qualities about graphs and different information we need to be able to get from a graph or information we need to find in order to graph. So here are a few concepts. First, when we graph a function, basically it's just the set of all ordered pairs, x comma y, that satisfy the equation. You've graphed lines before, maybe something like y equal 3x plus 2. And what we did is we just made a table of values and we found those ordered pairs in order to graph that equation, that line. And that line is actually a function. And when you were graphing lines, you may have found X-intercepts, which is the point where the graph crosses the x-axis. And to find an x-intercept, we always let the y be 0. You've also come across y-intercepts, an important point on the graph. That's where it crosses the y-axis. And to find a y-intercept, we always let x be 0. So for this particular problem, if I wanted to find an x-intercept, I would let the y part be 0. So I'd put a 0 in for y, and then I would solve it for x. So I would first subtract 2, then divide by 3. So the x-intercept would be negative 2/3. If I wanted to find the y-intercept, I would let the x be 0. And if I let the x part be 0, then I'd end up with y equal 3 times 0 plus 2. Well, the 3 times 0 is 0, so this would be y equal to 2. So the y-intercept would be 0, 2. So just reminding you of those concepts regarding x and y intercepts. So let's take a look at just some examples. We want to determine whether the given point lies on the graph of the equation, in this case, y equal the square root of 8 minus x. So I'm given a 4 for x and a 2 for y, so let's plug those in. 2 equal to the square root of 8 minus 4. And all we want to do is see if that makes a true statement. If it does, then that means the point 4, 2 lies on the graph of that equation. So the square root of 8 minus 4 is the square root of 4. And the square root of 4 is 2. So I end up with 2 equal to 2. So yes, that point lies on the graph of y equal to the square root of 8 minus x. Let's see if the point 8, 0 lies on that same graph. So I put an 8 in for x, a 0 in for y, and let's see what happens. So 0 is equal to the square root of 8 minus 8. Well, that looks true to me. I see 0 is equal to 0, so yeah, that point lies on the graph. Why don't you do that for this problem here? Take a second, pause the video, and do the same thing for this equation. So what did you get when you did those two problems? When I plugged in 5 for x and a 7 for y, I got a true statement. 7 equals 7. So the first one is a solution. When I worked on the other one, I ended up with a y equal to 11, and that is not equal to 0. I plugged in a negative 3 for x, a 0 for y, and we can see that these two guys are not equal to each other. So for the second one, that is not a point on the graph. Now, for this next example, we're given the graph of the equation, and they want us to identify from the graph the X and Y intercept. So right here is my y-intercept because that's where the graph crosses the y-axis. And so we want to state it as an ordered pair, x comma y. So this point would be 0, 3. The y-intercept would be 0, 3. What about the x-intercept, where the graph crosses the x-axis? Well, here is my x-axis, and here is where the graph crosses the x-axis, or in this case, touches it. That ordered pair would be -3, 0. So there is our x-intercept, -3, 0. So it's where we cross or touch the x-axis, where we cross or touch the y-axis. X and Y intercepts, two incredibly important points we need to be able to locate on a graph. Oh, here's one more. Let's determine whether the point lies on the graph of the equation. Tell you what, why don't you pause, work out these two pieces and see if the point lies on the graph or if it doesn't. So what did you get for the first ordered pair, 8, 0? I got that it was not a point on the graph because when I plugged in an 8 for x and a 0 for y, I came up with 128 equal to 9. And since those two are not equal, it's not a point on the graph. When I plugged in 0, 5, 2 times 0 squared plus 6 times 5 squared equal to 9, that one doesn't work out either because I get 150 equal to 9. So neither of those are an ordered pair or a solution to that equation. Okay, let's see what else we've got here. Okay, so we've been given the x values that they want us to plug into that equation. So we're going to plug in that value for x and then find the value for y. So I'll do the first one here. I'll plug a -1 in for x. I'll have y plus 5 times -1 equal -1 squared. Let me fix that up a little bit. That's a little bit better. Okay, and then we need to work it out, do the arithmetic, to find that value of y. So I'll end up with y minus 5 equal to -1 squared, which is 1. And when I add that 5 on the other side, I get y equal to 6. So the ordered pair is -1, 6. Now, I would like you to pause the video and do that for the next 4 x values. Now check your work. See if you obtained these same values for y that you see here on the document. This gives us 5 ordered pairs that we can now place on our coordinate system. If you got one of those values wrong, go back and check your arithmetic. You can also use your calculator to find those values. So let's graph this guy. So I'm going to start off with the point -1, 6, go over -1 and up to 6. That puts me there. Let me try a different size here. Let me see. Let me go to that and see if that looks better. -1, 6. Oh, much better. And then the next ordered pair was 0, 0. Right there. 1, -4. So I'll go over to 1 and go down to -4. 2, -6. So I'll go over to 2 and go down to -6. And then finally, I'll go over to 5. I'll stay. The last point was 5, 0. So I'll come over here, 5, 0. Now you may not realize this, but this is the graph of a parabola. So if I wanted to put this into my calculator to see a better graph, then I would type in here's my equation, y plus 5x equal x squared. But to put these in your calculator, you have to have it in a y equals format. So I would have to subtract the 5x on the other side, and it would be x squared minus 5x. And if I type that in my calculator, what I'll see is a parabola shape. So our graph would look something like this. What we want to get from this graph is both the x and the y-intercept. There is an x-intercept at 5, 0. There's another x-intercept at 0, 0. And that point 0, 0 is also considered a y-intercept because that's where the graph crosses both the x and the y-axis. Okay, so we found the ordered pairs, we plotted them, connected the dots, and we've got a parabola. This next one is parabolic in shape as well. So why don't you work on putting in these values for x and finding the corresponding y. I say pause the video. So the ordered pairs for the next function, y equals 6 minus x squared, come up to be -2, 2, -1, 5, 0, 6, 1, 5, and 2, 2. So those are the ordered pairs that are solutions to that equation. Now let's come down here and plot those. So let me get a bigger marking pen and let me go back to blue. So let's first mark the -2, 2. So I go to the left 2, up 2, puts me there. The -1, 5 means I go left 1 and up 5. So I'm going to go left 1 and up 5. 0, 6 means I go over to the 6, which means I go, 0 left or right, but I go up to 6. There's 0, 6. Now we've got the point 1, 5, so I'm going to go to the right 1 and up 5. And the last ordered pair is 2, 2. Go over 2, up 2. And you're probably noticing the symmetry. This is another parabola. It's opening down, and it looks like that. So we have our ordered pairs. We have our graph. And from that graph, we want to find X and Y intercepts. Well, they're not so easy to find because of the symmetry involved, and we don't have a 100% accurate graph. Now, the Y-intercept is pretty easy to catch. He is right here up at 0, 6. So 0, 6 would be my Y-intercept. So that one's not so bad. But to catch the X-intercepts, it's kind of difficult. So what we could do is just maybe give an estimation of what those 2 points are. Depending on how accurate your drawing is, it could be closer to the 3 or closer to the 2. But I'm going to call this 2.7, just because that's what it looks like to me. So I'll say the X-intercept, there's 2 of them, 2.7, 0, and the other one, I'll call him -2.7, 0. Let's just assume that's the point where it crosses the x-axis. So X and Y intercepts are important values to find from a graph. It's also important to be able to find ordered pairs for a graph. And this really isn't so bad. If you're given the x value, it's pretty easy just to plug that guy in. And then finally over here, we were testing to see if a point lied on a graph. And then we also found an X and a Y intercept from a graph. I hope you find this helpful, but if you have any questions whatsoever, email me, come by during my office hours. I am always happy to help. Have an awesome day.